Composite functions. Here we go. Composite functions. Think of it as a function within a function, and it is possible to have a function within a function within a function. It's possible, and the same theory will still apply, but we're only starting off with the idea of function, and you have another function within it. So, for example, if I gave you this function, you would have, most of us would have no idea what it looks like. Some of us may, some of us can probably decipher it, some of you might have seen it through Special or so. But let's assume that we haven't learnt this before. We've only learned quadratics, linear, cubics, quartics, sine graphs, and exponentials and whatnot. We don't know what the graph looks like. But I can predict, based on what we've learned so far, what a function is, domain, range, its properties, and I can predict what this graph should look like. Okay, and that's the skill that you want to take out of 1E. That's essentially what it is to analyze this type of function, what can it have and what can't it have. That's what you should be expecting at the end of year 12. They're going to give you a function you've never seen before. Okay, it's going to be some weird thing. It could have been like, I don't know, let's say root of x cubed plus 2x. And it'll say sketch that. And so you need to know the domain, the range, and you'll be able to visualize it. So if it's in exam 1, you have no calculator. So therefore, you would have to use what you know now to be able to extrapolate what it can look like and what it should look like. Okay? So let's take this apart. I've color-coded in red because I wanted you to see that we have learnt parts of these functions before. You might not know what 1 over root x is, but you have seen root x, and you have seen 1 over x. True? So 1 over x is a rectangular hyperbola. We know that one. Root x we learned from last year as well. We know that's a square root function, not a relation, so it's only the top half rather than the bottom half as well. And what happens when you put it in together, this is what I meant by a function within a function, because essentially what they've done is they said, let's call this f of x, and they said, let's call this g of x, and what they've done is they said, what if I replace the x variable with a g of x? I'm substituting, instead of the value, instead of 1 over 2, instead of saying x equals 2, what if I said x equals 2 g of x? So essentially what you'll end up with is you will have, and I'm going to write in blue so you can see what I mean, you'll have 1 over g of x. What if instead of saying x is equal to 2, then you would have f of 2 equals 1 on 2? Sure? Normally, if you say x equals 2 and you sub 2 into the function, you get 1 over 2, right? Instead of saying x equals 2, what if I said x equals to g of x? Then what you would say is you would say it's f of, and instead of 2, it would be g of x. So you substitute g of x in, and you would say it's 1 over g of x. But since g of x is equal to root x, then you would say this is essentially 1 on root x. Have I confused anyone? Just take a moment, try to think about that. So that's what I mean by a function within a function, because individually that was a function. It was just square root. Individually this was just a 1 on x function. But then what I've done here is instead of substituting x equals to a number, see if I said it was 3, then you would have said f of 3, which equals 1 on 3. If I said 4, you would have said f of 4 is 1 on 4. But what if it didn't have to be a number? What if it was a function? So what if I said x equals to another function? So that means you would say it's f of g of x, and it's 1 on g of x. But if g of x is a function, well, what kind of function is it? And in my case, I said it's root x. Therefore, I'm replacing the g of x as root x, and that's essentially what this is. And the nice thing is, because you know the properties of root x, and you know the properties of 1 on x, you know, and you can visualize what they both look like, you can predict what 1 on root x will look like. See what I'm doing there? Okay, this is called composite functions. So when you see this, there's a name for that. We call this composite functions, but how you read it is F-O-G, which means f of g. Okay, of g. And essentially that just means in your function f, you are substituting g of x in. That's essentially the language we're using here. Okay, so we're saying f of g, so that bracket there means f of g. That's how you read it. That's what it means. You're substituting a number into f. Obviously, you can write it the other way around as well. I could have said, let's substitute f of x into g of x. Then we would call that g of f. Okay, and this is what it would look like. So if I tried out g of f, which means g, and I'm substituting f of x into g, then this would be written as g of f of x is equal to, now instead of square root of x, it will be the square root of 1 on x, because f of x is what I'm substituting into x, right? So think about it, this is my g of x. Instead of the letter x, which is there, I'm substituting it with the function. So that's why I'm replacing the x with the function, and it looks like this. 1 on x. That's essentially what I'm doing there. So this is a composite function where it's root of 1 on x. This is a composite function where it's f of g, and that's 1 on root x. Okay? So the first step of your exercise in 1E is to do this. They'll give you two functions, and it'll say, find f of g, find g of f. It's getting into the idea that it doesn't have to be a number. It doesn't have to be x equals 2, it doesn't have to be x equals 3. It could have been x equals to a function. Okay? And that's the substitution. That's why I said you could have function within a function within a function. So you could have 3. You could have f of g, and within g you could have p of x, but we don't normally go to that level. Okay? If that visualization is still a bit confusing, I'll show you another thing to think about as well. You are used to seeing something like this. I'm going to just show you. We are used to seeing the machine box. I told you that those are functions. If it is a function, I'll put in x, which is your domain. And it goes into the machine, and whatever f of x is, it could be x squared, it could be root of x, it could be anything you want, right? As long as it's a function. Then what it does, because it's a function, it only spits out one unique y value. So then you get out the y, which is your range. True? That is your domain. You put it into the machine, it spits out a value. We call that the range. True? In our case now, what if I put a value in, it spits out, and whatever that is, I'm going to put it into another machine, hence function within a function. Okay? So this would go into a second function. Whatever that new value is going to go into the second machine, and that spits out a value. Now what I want you to really think about, this is where the whole theory comes about. In this particular case, when I put the x value in, which machine does it go into first? What's the first one? F of x. F of x, right? So I get f of x, but remember f of x, what value is that representing? F of x. Is it the y or is it the x? Y. Now think about it. If I put x in, so if I put x in to the machine and it spits out, what does that come out as? Y, right? Which is f of x. Because remember, when you write out your equation, you said here, actually, where did I write it? Oh, I rubbed it off. When we said f of x equals to root, was it root? No, it's 1 on x. 1 on x. Now have a think about this. If I did f of 2, what's my x value? 2. Yeah? No? X is 2, but what's 1 on 2? Half. Half. But what's that representing? Is that my x or is it my y? Y. So what this essentially is saying, so if I sub in 2, so when x is 2, y is half. True? The coordinates goes as if you put in 2, you get half. That's essentially what you're doing there. If I put in a x equals 3 into the machine, I will get 1 out of 3. True? If I put in 3, I get 1 out of 3. But what I want you to realize is that value, that half, is equivalent to f of 2. True? But once you have that f of 2, what are you going to do with that in the second machine? Is you're going to take that f of 2 and you're putting it into g of x. And so essentially what you're actually doing this, I'm going to do it in red so you can see the trail of what I'm doing. I'm doing x equals 2. I put it in here. This now becomes f of 2. F of 2, you told me, spits out 1 on 2. But then from 1 on 2, you're going to put into g of x, which now becomes g of half. And whatever g of half is. Okay, so that means it's g. And what is the function g? G was equal to root of x. So you're actually doing g of half becomes root of half. Okay, now, this final product is called the composite function. Why is it confusing? Is because you have to realize what you're actually putting into g of x is no longer the domain. What are you actually putting into g of x? The y value. And this is the first basis where students have to understand. That's why it's confusing. And I know it's going to take time. You're going to watch this video again to really get your head around that. It's the range. See, the way I'm drawing it. See, the first number, what was my domain? It was 2. That was my domain. Domain, my range is what I'm putting into the second function. Okay? Now here's the issue. I'll show you what the issue is. When we're talking about g of x is the square root of x. What can't square root of x take? Negative numbers. I can't do square root of negative 1. But what's f of x, which is 1 on x? Can it take any negative numbers? Yes. Yes. So here's the problem. I'll show you what the problem is. See, I chose a positive number, so it all worked out, right? But if I chose x equals to negative 1, this ends up being now f of, what? It's not working anymore. F of negative 1. True? F of negative 1 ends up being 1 over negative 1, which essentially is negative 1. So that works. The first machine works. If I put a negative 1 into 1 of x, that works. That gives me negative 1. But the problem is, if you take the range of this, which is the y value, negative 1, if you put into g of x now, you will not have g of half, but you have g of negative 1, which actually means now you are doing g of negative 1, which is square root of negative 1, and what's the problem there? No solutions, undefined. So that means this composite function cannot have a domain of negative 1. But what other numbers can it take? And that's why we've learned domain and range. What I can already see for f of x and g of x here, whilst it works for the first one, it's not going to work for the second one. Your skill in 1E, which is the toughest part when you get your head around, is to determine all the numbers that it can't take. Because right now, I can't take any number I want. There's a restriction. There's a restriction on the problem. And that's what I mean by the skill of analyzing the function. Okay, now what I've actually done here is a g of f problem. This is f of x. I'm going into f of x first, and I take f of x, and I substitute in g of x. That's why we call this a g of x problem. G of f of x problem. See what I'm doing there? I'm actually saying g of f, I'm substituting whatever f of x is, and that's what I just did. I just said, sub in a negative 1, f of negative 1 becomes g of f of negative 1, but f of negative 1 was equal to negative 1. That's why it became a problem, because g of negative 1, I can't do 1 over negative 1. That's undefined. So when they tell you in this problem, this whole exercise, that towards the end, the question is, well, how do I change it so that it works? The only thing you can change is the number you decide to put in. I decided to put a negative 1, but I can choose not to put a negative 1. Because whatever I put in here will give me the end result for f of negative 1, which is here. So if you think about independent and dependent variables, my y depends on what I put into the machine. And the question is, what can I put in? Now we know we can't put in negative numbers. Can we put a 0 in?
No.
Why?
You can't do g of x, it's undefined.
Very good. See, g of x, you had to look at the condition of g of x. Whilst I can square root a 0, okay, the first function had a restriction. And what's a restriction? It can't take 0. As soon as I put 0 in, if I put x equals 0, it goes in here, and I say 1 on 0. 1 on 0 is undefined. If it's undefined, then what am I putting into g of x? It's already undefined. I can't get an answer. So we just figured out, okay, I can't put negative numbers, because if I put negative numbers, it works for the first one, but it doesn't work for the second one. I can't put in the 0 because it doesn't work for the first one, but it works for the second one. So what numbers can I really use?
Positive numbers.
Only positive numbers. And what's the notation that we learnt from the first lesson that we can say that it's only all positive numbers excluding 0? R plus. So here, if I wanted to make this g of x possible, if I wanted to sketch this on my calculator, the first thing you have to be able to tell it is that I can't have any negative numbers or 0. It's R plus.
How do you have 0?
Because if you put 0 in, f of 0, which is here, 1 on 0 is undefined. If it's undefined, then you can't go on. But can you see what I'm doing there? I'm using machines so you can visualize what you're actually doing. You're putting in It has to work for both. Okay, and over time, what we're actually doing is a definition. We're making sure that the range works for the domain of the second function. Because the domain here for g of x, we said it can only be positive numbers and 0. Then we have to make sure the range fits that. Because whatever the y values are, it has to work for the second one. Okay? And it's the same with the domain for the first one. All right? That's a lot of information I just chucked into you. We're going to do a couple of practices just so you can visualize what I'm doing here. But what I just did was a g of f problem. Now let's try to switch it around. What if I did f of g? Okay, let's do an f of g problem here. Okay, so let's do it again. I'm saying that f of x is 1 on x. Okay, and now I'm calling g of x root of x. Is that right? That's f of g. Yeah. So now we're doing f of g. Okay, we're doing f of g. If I'm doing f of g, which means that in order to get this graph, h of x, I need to know what happens when I substitute g of x here. Now, if I sub g of x into the problem, this would mean I have, let's say, I'll draw the boxes here. Let's fill out the box. If I'm talking about an f of g of x, if I use an x value, which machine will it go in first? Is it f or g? G. And that's the part that you have to get used to understanding. So when you write f of g of x, if you think about it, the number that you're putting in replacement is here. But it's g of x first, and whatever that answer is, then you do f of that. So you're reading it from the outside. Yeah, so g of x happens first. So that means my machine is g of x first. And then whatever spits out, I do f of that. Okay, so whatever g of x spits out, I'm going to put into f of x. And then it spits out the value. Actually, I should do this just to make more sense. That's essentially what I'm doing there. Okay, so I'm putting the domain. I put in a domain into the first machine, which is g of x. G of x will give me an answer. That answer is your y value, which is the range. The range goes into the second one, okay, which goes into that x there. So the range is g of x. So it's f of g of x is what spits out. The problem is, what if the y doesn't fit the restrictions of the second function? Okay, because we know the restrictions. We know that for g of x, which is a root function, what's the restriction on a root x again? Negative numbers. We can't have negative numbers. So x is an element of r plus union 0. It can only be positive numbers including 0. The restriction on the first one is what? What's the restriction on a 1 on x function? Just 0. Good. Very good. It can all be all real numbers except for 0. So if we look at this now, the first restriction is as long as x is a positive number including 0, it's all good. But here's the issue. Here's the issue. Now I'm going to try to do a table so you can see. Domain, range, f of x, g of x. You're going to learn to use this table as well when you're first sort of getting into composite functions. Let's have a look at this. We found out the domain for f of x was r. Actually, I should do an interval notation so you can see. Actually, no, I'll just do r excluding 0. Okay, g of x, we know that the domain was r plus union 0. What's the range of g of x? Including 0. So r plus union 0 as well. Good. What's the range for f of x? Good. All real values except 0. Good. Now we've got our domain, I've got a range. Now let's look at what's actually happening here. The numbers I'm going to put into g of x is the domain. So I already said the numbers I'm going to choose is all positive, including 0. But then if that's my domain for g, remember what's the restriction for f of x? It said it can only be real numbers excluding 0. What's the problem in these two already? What can you see? So if I spit out a range, What's the problem? Yeah, one of them can include 0, one of them can't. So if I have a look at this, if I substitute g of x, it spits out a range, and I'm going to write in green so you can see. Whoops. So I want you to see, in green, it's going to come out as the range, but the range can only be r plus union 0. The problem is that this is not a subset of r excluding 0. If you draw a number line, it makes a lot of sense. Think about a number line. I draw a number line so you can see. If we did a number line right now, if 0 was here, r excluding 0 would be this. Don't include the 0, but you can take every other number. True? That was f of x. But then if you look at g of x, let's have a look at g of x. G of x said include 0, but only the positive. Those two have a mismatch, and the only mismatch that they both can't have is right at 0. Now, in other problems that you're going to get, there are going to be other issues that are going to arise, but your job is to find out when does this fit the second one, because we're taking g of x and we're putting into f of x. So I need to make sure the range fits to the domain restriction of f of x. And that's the first property that you have to understand. And it will come up in your exams and everything like that. So I'm going to write down the first property and you're going to copy this one down. Okay, I'm going to write it down. So ignore all that. We'll get back to that. This is your first property. And most students memorize this. They'll write in their sort of cheat sheets and notes and whatnot. A lot of students don't understand that idea. And that idea is very logical. If you draw out your machines, it makes sense. The range of your first function, in our case, if we said f of g, the range of the first function has to fit the domain. Otherwise, it's going to become an issue. So if I draw the machine again so you can see, it'll be an issue if I decided to put 0 in, x equals to 0, and I know root of 0 is possible. That's great. It comes out as y equals to 0, which is true. But then as soon as you put that into f of x, that's a problem, because f of x was 1 on x, which is 1 on 0, and that now becomes undefined. So what we realized was the crucial step is right here. That's a crucial step. Right there determines, what it actually determines is, let me do the blue. Right here, the range of your first function has to fit. Okay, this means subset, by the way. Subset. It has to fit the domain restriction of f of x on a logical basis, because whatever is going here, if it doesn't fit that one, well, there's no point doing it anymore. We just got to make sure the numbers you choose for the domain spits out a value that's going to fit for the second one. And the only way to change the range is the domain of the first. Yeah. Ooh, oh, I see what you're trying to say. No. But you're right, yes.
How do you figure out the range of the composition?
Good. Okay. The range of the composition can only be done by visualizing the graph.
There's no way that I can
No. There's not a real way. We can only figure out the domain.
So they're not going to ask us that, right? Unless they ask us.
Yeah. No, they do ask you. Usually it's a graph that you can predict. Usually it would be a graph that you can predict, but you're right. You're right. So with the same example before, with 1 on root x, I can only know the domain for this, but I won't be able to figure out the range unless I picture the graph. And if I can picture the graph, then therefore I can work out what the range could be. Okay? Now, here's the first property. That's your first property, and all I need you to understand, it's a two-machine process, and take your time to understand this idea, because if you understand what I'm saying, you can go to the last few questions and do exercise 1E. If you don't, you're going to be stuck in the first half, okay, which is just identifying f of g and g of f. The hardest part of my lesson today is getting your head around why it's the range of g being the subset of the domain of f. Normally drawing the number line really illustrates the idea. Okay? So you need the y values of the first function needs to fit the domain of the second function. That's essentially what I'm saying there. Okay? Draw a number line out, but this here represents f of g. It's all sort of switched around, that's why it's a bit confusing. Alright?
But that doesn't
It doesn't mean.
So like if I have f of g, then it's like every single number, and then f of every single number that you can ever imagine,
No.
and then g of x is only positive numbers.
Because the domain is the x values you choose.
But it can't be the other way around. Does that make sense?
Yeah, I know what you're trying to say.
Every number.
Let me clarify that with the class. It's a good question what Alfie's asking. All right. Just to clarify, I need you to just listen to this second part here. Alfie asked, listening, if f of g of x, which is the composite function, okay, he's asking, is the domain of that equal to the range of g of x, okay? And whilst it makes sense, because you're breaking it into different functions there, remember, there's only ever a one range, and there's only ever a one x. Because in this notation I'm writing, what's my domain? Just looking at this only, what's my domain? Where's my domain coming from? Which is from g of x, but from g of x, where's the domain coming from? It's x. X has always been the domain, because the domain is the x-axis, yeah? So if I drew out a graph, this is your x. X doesn't know anything about G and doesn't know anything about F. X is on its own. It's on an x-axis. So if I chose the number 3,
No, the other way around, sorry. G of x is a subset of f of x.
if I chose the number 3,
The other way around.
that is my domain. That's my domain. X equals 3, that's my domain. Those are numbers I'm choosing. Domain is the selection of x-axis values you're choosing. So if that's my domain, g of x is the y value of my domain, and that is not the domain of f, because when you're sketching f, this whole thing
But which one's the subset?
is the range. That whole thing is a value. At the end of the day, when I put a number in, it spits out a final value. So if you think about the machine again, if I put in,
Within has the
let's say 4, square root of 4 becomes 2. 2 goes into this machine, and I get 1 on 2.
I know you're
So if you think about the machines, I put in a 4, and at the end of the day, it spits out half.
okay, so
This is my domain. That is my range of the composite function. Because the composite function is the machine. Okay, where if you broke it out individually, then yes, domain, range, function. Domain, range, function. But if it's together, this is the domain, this is the range. Yeah.
Is the domain of the composite function the intersection between the domain of the first machine and the range of the second?
Not intersection, you're right. It is the domain. Okay, say it again. Let me just fix your terminology. Say it again.
Is the domain of the composite function the intersection between the domain of the first machine with the range of the second machine?
No. No, it isn't. I think you might have wanted to say it's the other way around. The domain of the first machine was... Oh, I see what you're trying to say.
Yeah.
I'm just trying to see if that even works. I'm trying to think of a problem that...
Because
Yeah.
if your x value doesn't fit the first machine, then naturally it's not in the domain of the composite function. And then if it doesn't fit the range of the second machine, naturally it's not in the domain of the composite function. So therefore, for your domain of the composite function, your x value has to fit in the domain of your first machine and the range of the second
We were talking
machine.
about yesterday. It's a bit.
Yeah. I understand what you're saying, but we're now confusing...
Or maybe I've got the range of the second machine. I have no other.
Yeah. That's what I know. All right. Let me just clarify this for you so that we don't get mixed up on a couple of things here. Okay? Because we're mixing up a few things. Here we go. When we say composite function, listening.
you even have the value.
When we say composite function, let's say f of g of x. This is our current problem, right? You can't call it a function until it works, until it's defined. Okay? So how is it defined? The first problem was the first property that I said. It's only defined, it means it only works if the range fits the domain of the first one. So once that's checked off, now we can say, okay, that exists. So essentially what we're doing this. We're saying this is the machine. then the first question is, what is the domain of the composite function? Means what number you're putting into the machine. The range of the composite function is what's the final answer. So logically, what's the number that you first put in this whole process is the domain of the very first function. Hence the second property, which I was leading you guys to, which is coming up, actually it's not even there, here. The second property, which is not even there. Wait, did I even do it? I normally have a second property somewhere. Alright, don't worry. I think I might have mixed it up. It's not, it should be there. There's the second property. No, doesn't say. Sorry. I'm still right though. Okay, so here we go. Going back to my point, what I'm trying to say is there are two properties to exercise 1E that you have to get your head around. First one was, does it exist or does it not? So the function is not, when we say exist, it means does it work? It only works as long as the range of the first one works for the domain of the second one. Okay, that's the first one. After it works, then we say, okay, cool, this thing exists. F of g of x is a machine that does work. Then we draw, and as a whole, this is a machine. That's a function. We just call it composite function, right? But it's a function. The number that you put into it is the domain, and the number that comes out is the range of the composite function. So another way of thinking about it is this composite function is 1 on root of x. The number that I put into 1 on root of x is obviously the domain. So this is domain. Good.
Is that right?
Yes. Yeah. That's what I'm trying to say. So the domain of f of g of x comes from putting this in. But if you look at the process that I went through, what was the first number I put in? That was the domain of the first one. So hence the second property is here. I'm going to do it in blue. Domain of f of g of x is equal to the domain of g of x. Okay? Because that's what we're saying. We're saying the domain is the number of x values we're putting in. This is the range. The problem is we don't know what the range is unless you can visualize what the graph is, or you can plot each value in, and then you can see what the graph looks like. But the domain of f of x, or the composite function, you can find out because that is the domain of the first one. That's essentially what I'm trying to say. Only two properties. Yes? No, so don't confuse. Yes, the x value is substituting into g of x ends up being the y values for g of x, and then it goes into f of x and you spit out a value. True? But this whole process is in this machine. I've just broken up what's in this machine and broken it out for you to see. So essentially we're just asking, when we say domain of a composite function, we're saying, what are you putting in? And the range means what's coming out. Just like this one, if I said, what's the domain and range of g of x, you would say, what are you putting in? What are you getting out? If I said, what's the domain and range of the second function, you would say, what are you putting in? And what are you getting out? True? It's just that this whole thing is in here. Yeah? So another example is this. If I gave you guys, listening, if I gave you guys a really random one, let's say I gave you this. Y equals to root of x squared minus 36, right? If I asked you to draw a machine for this, this is what you would have done. You would have said y equals x squared minus 36. If I put in a 7, then what you would have is 7 squared, which is 49 minus 36, and that's what, 4, 5, wait, no, 9 plus 4, is that 13? 13. So then y equals 13. You would say that the coordinates is when x is 7, y is 13, true? So if I asked you what is the domain and the range of this crazy function, you would have told me that the domain is here. And if I asked you what the range is, you would have said it's here, true? It's just that I've broken this apart. I've broken this machine into two parts now. I've broken it up into the first one, which is x squared minus 36, and then I said the second machine is a square root of x. I've only just broken up the process. But essentially, this is my composite function. So what is the domain? It's what you're putting in. Hence why what you're putting in is into the first function. So what you're putting in is x squared minus 3. So hence the domain of G,
We're out there, right?
and then hence what's outside is the range. Do you see what I'm doing there? Yeah? So this is just describing to you what's happening, but essentially this is all you're doing. What goes in is the domain, what goes out is the range.
When you say domain range, do you mean x and y value?
Yes. Yeah. That's traditionally we say x and y, but sometimes when you're dealing with applications, it could be distance versus, I don't know, time, or time versus distance. You know, then we don't say x and y, it would be t and d. That's why we say domain range, and it's exclusive of x and y. But conventionally, for you to understand that normally x-axis is the domain, and the y-axis is the range. Yeah.
The domain, including 6, negative infinity to 6.
Not including asymptote.
Good. Yes. So I'll say it again. No, wait. Let me fix that.
Negative infinity to 6.
Say you put 0 into the first one, and then
To make this composite function work? No. It would be. Actually, we're going to do this example. Actually, let's do an example just to get our heads around it. Yeah. Do I have enough time? 3 minutes. Maybe not. I'll do it in the next lesson. Wait. All right.